Question number 11. We want to find the domain of the function f of x equals the square root of 2x cubed minus 98x by the following methods. Part A, we're going to use algebra. In part B, we're going to graph the function in the radicand and determine intervals on the x-axis for which the radicand is non-negative. So in part A, we're going to use algebra. And so when we talk about this expression, which is 2x cubed minus 98x. Okay, initially what we want to do, and what we've done already in the previous examples, is that we want to figure out when is this expression going to be greater than or equal to 0. Now, in order for us to be able to do this in this scenario, because it's a cubic expression, we want to be able to factor this using the zero product rule. So we're going to look at this as if it was an equation and not an equality. So we're going to have 2x cubed minus 98x, and we're going to set that equal to 0. And then we're going to factor out the 2x, and what's left is x squared minus 49, and that's equal to 0. And what we end up getting is 2x times x plus 7 times x minus 7, and that's equal to 0. And now the next thing we want to do is then set each equal to 0. So we have 2x is equal to 0, x plus 7 is equal to 0, or x minus 7 is equal to 0. So we have x, which is equal to 0, or x is equal to negative 7, or x is equal to positive 7. Okay. Now what these numbers represent are the coordinates of the x on the number line, and we're going to use those as our boundaries. So here we're going to plot 0, and then over here we have our negative 7, and then over here we have positive 7. And so what this does is those numbers separate these boundaries. And what I mean the boundaries is that we have a boundary here, which is interval 1, this is interval 2, this is interval 3, and this is interval 4. So the interval for 1 goes from negative infinity to negative 7. Interval 2 goes from negative 7 to 0. Interval 3 goes from 0 to 7. And then interval 4 goes from 7 to positive infinity. So the next step is that we want to now test each point from the interval and plug it into our function. So we can pick a value in interval 1 that's got to be in interval 1 but not negative 7. So what we're going to do is we're going to pick negative 8. Okay, now instead of using this original function or this function, we're going to use this function because it means the same thing. And what that allows us to do is it just allows us to plug in x and be able to figure out what we're going to get quite easily once we put in the number that we have for x. So let's go ahead and do that. So we have 2 times negative 8 times negative 8 plus 7 times negative 8 minus 7. So we end up getting negative 16 times negative 1 times negative 15. So we end up getting positive 16 times negative 15. Okay, now we don't necessarily need to go any further with this as multiplication. We just need to determine whether it's going to give us a negative answer or a positive answer. Well, this is going to give us a negative answer. So in interval 1, we're going to get a negative result. Now what we're going to do is then we're going to select a point in the interval 2 between negative 7 and 0. So let's pick negative 1. Because negative 1 is in between negative 7 and 0. So we can say 2 times negative 1 times negative 1 plus 7 times negative 1 minus 7. So we get negative 2 times positive 6 times negative 8. Okay, so when we multiply that all out, again, we don't need to worry about multiplying the numbers out. We just need to know whether it's going to give us a positive or a negative result. Well, we have a negative times a negative, so this is going to give us a positive result. So in this interval 2, we're going to get a positive result. Okay, let's take a look at the next interval. So in between 0 and 7 for interval 3, we can pick positive 1. So we're going to have 2 times positive 1 times positive 1 plus 7 times 1 minus 7. So we're going to get 2 times 8 times negative 6, and that's going to give us a negative answer. So we're going to get a negative result in the third interval. And then the final interval, in between 7 and infinity, we can use positive 8. So it's going to be 2 times positive 8 times 8 plus 7 times 8 minus 7. So we have 2 times 8 times 15 times positive 1, which is going to give us a positive result. So now the next thing we need to determine is if these parentheses should be brackets. And the reason why we need to know if they're brackets is if negative 7, 0, and 7, when we plug them in, it's going to give us 0 under the radical. So let's go ahead and plug in x equals negative 7. If we plug in negative 7, we get 2 times negative 7, negative 7 plus 7, times negative 7 minus 7. So here we have 2 times negative 7 plus 7 gives you 0, and then this is negative 14. So regardless, we know that this is going to give us 0. So at negative 7, we know that instead of it now being parentheses, we have brackets. Next, we plug in 0. What happens when we plug in 0? Well, we get 2 times 0 plus 7 times 0 minus 7, and that gives you 0. So we can also then include 0. So now these become brackets. And then if we try positive 7, we have 2 times positive 7 times 7 plus 7 times 7 minus 7, and then we're going to again get 0 here. So that means we can also then include the positive 7. So we have brackets for those. So now when we want to write our final conclusion here for this part, we know that the interval or the solution in interval notation is going to be intervals 2 and 4. And intervals 2 and 4, going back up here, go from negative 7 to 0, both with brackets, union, and then bracket 7 to infinity. Okay, so that is the algebraic way of being able to determine the interval notation of part A. Now for part B, they want us to graph the function in the radicand, meaning this function, and determine the intervals on the x-axis for which the radicand is non-negative. And so what we want to do is we want to graph this function, and we're going to graph it in Desmos. So let's go ahead and do that. So we're going to put in 2x cubed, and then minus 98x. Okay, so we're going to zoom out here because we want to see this entire graph and see what's happening. Okay, so here we can see that this graph is possibly, going up and then down here. So it's going up pretty high. So we kind of want to minimize our x-axis. So if you hit this wrench over here, and we can make our x-axis, let's make that, let's say, negative 10 for the minimum. And then we'll make it positive 10 for the max. So we can see this graph look a little bit better than what we saw earlier. Okay, so this is what our graph is going to look like. So let me go ahead and copy this. So as you can see here, when we graph, we're going to be able to determine this interval a lot quicker than what we did in this first part. So just like we saw here on our number line, this is exactly what we're looking at over here. So on our number line, okay, you can see here that we're going from negative infinity, and we know we can include the 7 here because it's negative 7, excuse me. And then we're going from negative 7 to 0, and then from 0 to 7, and then from 7 to positive infinity. Okay, so I want you to look at this interval here. Okay, so this line. So we have our intervals. Okay, now I'm going to label them different colors just so you can see what's happening. So everything from here down is below the x-axis, which means that that represents a negative situation. So that interval between negative infinity to negative 7 with a bracket is a negative, just like we saw over here, interval 1. Now, if we take a look at this part here, okay, that's above the x-axis, and it's positive, meaning it's above the x-axis between negative 7 and 0. Okay, and then when we start here at 0, it's now again below the x-axis, which means it's negative, and it's negative for the interval between 0 and 7. So again, you can see here, that's where it's negative. And then it then increases, and it doesn't stop here, so that means it's positive here from positive 7 to infinity. So you can see where it's positive. So from here, we can then determine, just by looking at the graph, where it is positive, without having to use algebra to get that information. So graphing is going to get you your solution a lot quicker than doing the algebra for this particular problem.